Hello and welcome back to Calculus 1 in this fine Saturday morning, right? Everyone's cheerful and happy because we are about to do fundamental theorem of calculus. See what is so interesting about it. So you are familiar with the fact, hopefully, that derivatives and integrals are opposites of each other. So the derivative of x squared was 2x, and the integral of 2x dx was x squared plus some unknown c. So now what I can do, is this thing going? Yes. Is I'm going to say that fundamental theorem of calculus part 1 is the good old definite integral. Integral a to b of f of x dx is equal to any antiderivative capital f of x computed from a to b, which is f of b minus f of a. So this is the part 1. It's a definite integral. And we said that we can find area under the curve using this. And we also said in class that area and the value of definite integral are not necessarily the same, because function might dip below x-axis and that creates negative area, and then they subtract, and right. So area under the curve and definite integral are not always the same value. If the function dips below x-axis, there will be negative area, in which case, right, we don't have the situation. So if I have a function f of x like this, and then you go from a to, let's say, b, so over here area is equal to integral a to b f of x dx. The other case is when the function dips below. Let's say this is your a and this is your b, in which case you would have this area and this area. In this case, area is not the same as integral a to b f of x dx. As we saw in the previous section, in order to calculate area, you have to go integral a to c, so there will be a c there, of f of x dx plus the absolute value integral c to b f of x dx. So you have to be careful. This is part 1 of fundamental theorem of calculus, right? We define the definite integral, the way to compute the definite integral, and we say it's used to calculate areas under the curve, but then again you have to be careful about the area under the curve. Depending on the function, you might be able to do it easily, or you'll have to annoy yourself with the longer calculation as you can see. Now, the part 2 is the one that we focus here. So, fundamental theorem of calculus, part 2. And that one states that the derivative of the integral a to x of f of t dt is going to be f of x. That's the part. So what's so fundamental about this? Well, the fact that these guys technically cancel. And then you just have f is f. Now it's very easy to show that. Let's go blue. The derivative of the integral using the part 1 is just going to be any antiderivative of t computed from value a to value x. So all I did is I integrated and I got this capital F. Now it's capital F of x minus capital F of a. When you take the derivative in respect to x, you get f of x minus 0, which is just f of x, because f of a is a constant, it's a number. Derivative of that number is going to be simply 0. So this is actually a proof that works. If you take the derivative of the integral, they cancel each other out, which is why anytime you integrate, you can use the derivative to check your answer, which is amazing. So, if the problem over here says ln t, then this is ln x. If this is sine t, this is sine x. If this is 1 over t, this is 1 over x. It's always the same function. There's just a variable x. Now, why does this work? Why are these guys opposites of each other? Well, let me write the formulas for both, and then you tell me why they're opposites. I have the derivative written as the limit h goes to 0 of f of x plus h minus f of x divided by h. And we have Riemann integral a to b of f of x dx, which was the limit n goes to infinity, summation 1 to n of f of ci delta x. Who can tell me why are these opposites? Oh, you know already.
I'm not going to read it.
Okay, let me see. Let me see, some thinking.
Is it on top of that summation thing?
N. Yeah, lowercase n.
So, did you figure it out? What's opposite? Come on. I guess you'll have to ruin it for everyone. Great. What else? What else is different? Oh, look at the formulas. What's different between Formula 1 and Formula 2? Which is the reason why these undo each other.
One's integration and one's differential.
Well, that's the given, but I want to look at the formulas on the right and say what's different. Should be obvious. So we have 0 and infinity. Guys, we have subtraction and we have addition. And we have division and multiplication. They're completely opposite. You see that? The derivatives subtract stuff, integrals add stuff. Derivatives divide, integrals multiply. 0 and infinity, and there's also this part where x plus h and b minus a over here, but yeah, that's now pushing it. Good. So now, what is the derivative of 3 to x of sine t dt?
That is a 3, right?
There is a 3. Indeed, that in my algebra classes, the students say, "Oh, that's a 7 for an hour." Every time I would write 7 on the board.
But your 7s are
The line. It's a European thing.
I know this.
The right way to do it. 7 is 12. Great. Correct. Answer is sin x. Nice. All right. Take a break.